All right, everybody. Welcome to the lesson 1.1, which is going to be right triangle trigonometry. Now we're starting off with right triangles for two reasons. One, a lot of you are in physics, and physics is very much a triangle math type of subject. So that's something that we definitely want to get covered and reviewed at the very beginning of the semester so that you're set and ready for the rest of the semester. The other thing is some of you may not have had trigonometry yet. And so I want to make sure that we're all on the same page and we're all getting started at roughly the same level. Okay, so we're going to first kind of introduce what we mean by right triangle trigonometry. Then we're going to use the formulas for trig to find the sides of triangles. Then we're going to use the formulas for trigs to find the angle of triangles. And then we're just going to do some basic trig identities. Okay, so the first thing is to talk about what we mean by a right triangle. Now, a right triangle is any triangle that has a perfect corner right here. That's what we're talking about, is that perfect little corner. Now, one thing that gets people is the orientation. Now, in this lesson, I'm going to have all the triangles like this, what we call in the first quadrant. If you think of this like a coordinate system, okay, of X and Y, this is the first quadrant where everything is positive. Okay. If we were to write this in the second quadrant, this would be Q2 right over here, then it would be a triangle that looked like this. So here's your H, A, O, perfect corner, and here is your angle X. Okay? Yep. All right. If we were to draw it in quadrant 3, it would look like this. And that would be quadrant 3. And if we were to draw it in quadrant 4, it would look like this. Okay. And all the formulas work regardless of which quadrant it's drawn in. The key is that you have to kind of orient it correctly. So look at the shape of your right triangle, its orientation, and then use this little blueprint to figure out what your letters are, because that's the hardest part of right triangle trigonometry, is just knowing where the numbers from your triangle fit into the formulas. So you've got the Pythagorean theorem, which is 500 BC. So that's a 2,500-year-old formula. And then you've got sine, cosine, and tangent, which are around 900 AD. Well, they were known before 900 AD. How far before, we don't really know, but we've got documentation around 900 AD with them on it, referencing other things. So we know they're probably at least 100 or so years before that, but at least by 900 AD, we had the right triangle formulas all ready to go. All right, so let's work a problem here. So right here, we've got the hypotenuse is 40. X is 15 degrees. And we are looking to find side O. Now, the important thing is going to be that I don't think I have a calculator on me. So this is going to be interesting. So we've got sine X is equal to O over H. Cosine X is equal to A over H. And tangent of X is equal to O over A. Give me just a second here. seeing if someone can bring me a calculator. Because this program doesn't have a pause button on it, so I can't pause and go do that. So we know that the hypotenuse and the angle, so that's 15 degrees, and that is 0 over 40. This is cosine of 15 degrees, and I do not know what A is, over 40. And this is 15 degrees, and this is 0 over A. Now I want to find O. That's what I'm looking for. So to find O, this one is not going to be helpful at all. So if I'm looking at it like this, that's not going to be useful to me at all. So now I'm down to sine and tangent. This one's got too many missing pieces. So that's not going to help me. So this is going to be that right here. So sine 15 degrees is equal to O over 40. And then all I'm going to do is solve this. I'm going to take this, move it to the other side through multiplication. And this will give me 40 times sine of 15 degrees is equal to side O. Okay. Now, when you're doing this, you want to make sure your calculator is in degrees. So I think I'm going to pull up something, see if I can find a calculator app on my on the internet. Let's see if I can put this in degrees. All right, so I've got my calculator here. So let's make sure I'm in degrees. I am. And that's going to be 40 times sine of 15, and that is 10.35 is equal to side O. And so I found the side of the triangle that I needed. All right, so let's look at something like this right here. I know that A is 13. Let me write it a little bit better. In case you are writing on a tablet and you want to write smoother, the more you zoom in, the smoother you'll write. Okay, so A is 13 and O is 8. And we want to find the hypotenuse. So all I'm going to do is use the Pythagorean theorem. Remember, that's going to be A squared plus O squared is equal to H squared. Okay. There's a reason why that formula that is 2,500 years old is still being used today. So that's just going to be 13 squared plus 8 squared is equal to H squared. So I use my calculator, and that gives me 233 is equal to H squared. And all I'm going to do now to finish this out is move that over, and that gives me the square root of 233 is equal to H, which means the hypotenuse of that triangle is 15.26. Cool. So that's something that is extremely useful, being able to use the Pythagorean theorem, being able to solve for something that's to the second power. You know, just move that second power to the other side and turn it into a square root. All right, now, one of the most important things that you can use trig for is to find a missing angle, okay? Now keep in mind that when you're using this, it only finds the angle on the inside corner here. If you want to find the other angle, there's a formula for that. You subtract the inside corner from 90, and that will give you the other angle, okay, that top corner up there. So you do want to be careful about that. All right, so I know that A is 13, and I know that O is 8, and this is probably the most common one, where you know the two sides. Knowing a hypotenuse is not easy in real life, and knowing the angle is not easy in real life, but knowing the two sides is actually the most common thing to be able to find. So this is a very important thing. Going through our three formulas, we'll find out that this one uses tangent of x is equal to side O over side A. So just plug my information in. And that is going to be 8 over 13. Okay. Now, when it comes to trig functions, when you move a trig function to the other side, not the whole function, just the trig part, not the angle as well. When you're moving just the trig part to the other side, that's when it becomes the inverse. Okay. So that's going to be tan inverse. So this will turn into angle x is equal to tan inverse, also known as arctan, of 8 over 13. Making sure my calculator is in degrees, I hit tan inverse, 8 divided by 13, and my angle is 31.61 degrees. Okay, now keep in mind what I've just found. I've just found this part right here. Okay, if you want to find this top angle up here, it'll be 90 minus 31.61, which equals 58.39 degrees. Now, I bring this up because sometimes you do need to know that top angle. So there will be times where you need to know every single corner of a triangle. And so that's the quick and easy way to find that top one. Okay. All right, so let's move on to the next one. So right here, we know that side H is 42. We know that A is 28, and we are trying to find our angle X. Plugging into all three formulas like we did before, we'll see that this one is cosine of X is equal to A over H. Now, once you've done several of these, you know which one of the 3 or 4 formulas it's going to be. But until you get a handle on it, you may have to write out all 3 and just see which one has the fewest missing parts. And that's going to be 28 over 42. And just like we did before, I'm going to move that trig piece over, and that'll be cosine inverse. And so this gives me x is equal to cosine inverse of 28 over 42. Type that into my calculator. And I get 48.19 degrees. Okay, so there we go. Any questions about this one? Any questions at all? All right, so the last thing that I want to talk about on this first lesson is trig identities. Now, this is going to become extremely important later on in Unit 2, and it'll be very important in physics and very important in Calc 3 and very important in Calc 4. Basically, from here on out, trig identities are going to be important. Now, trig is just so useful, it's just so over the place that it's never going to go away. And so what these trig identities do is they're ways to try to simplify trig formulas. Okay, so let's look at this one right here. This right here is the most common situation to occur because trig has been converted into rotational motion. So this right here is actually, some form of a circle. Okay? And using trig identities, I can simplify this down into something that I can work a lot nicer. Okay? So as long as the inside match, okay, this piece has to match. Okay. I'm going to pull out the 7. So this gives me 7 times sine squared 15x plus cosine squared 15x. Okay. And if we look at our trig identities, sine of something, it doesn't have to be x, it should be whatever, as long as they match. Okay, that's all that matters. Sine squared plus cosine squared is equal to 1. Okay, so this whole thing right here is just 1. And so that simplifies to 7. So that right there is one of the most important identities that there is. It is also the most useful. You use it the most often, in Calc 3 especially. It comes up all the time. So you definitely want to become familiar with trig identities. And there's a ton of them. I just wrote down some of the most common ones. All right, so let's look at the next thing. So right here I have sine squared of 60x. Now what we'll talk about in the next unit is when things are raised to the second power, they just become a heck of a lot harder to work. So there is actually a formula that I can use. Sine squared, and how did I write it here? With an x, okay. Sine squared of x is equal to 1 minus cosine of 2x over 2, okay? So right here, I have sine squared of 60x. Whatever is in here gets doubled. So that's going to be 1 minus cosine of 120x over 2. Okay, so whatever is in here gets multiplied by 2. That's all that means, times 2. So that's just times 2. Okay, so this right here is going to be 3 times 1 minus cosine of 120x over 2. And if I multiply that through, that's going to be 3 minus 3 cosine of 120x divided by 2. And then I can split that in half, and that'll be 3 halves minus 3 halves cosine 120x. And here it is, completely simplified down. And And even though it looks bigger than what we started with, that is actually a bazillion times easier to work with than something trig related raised to a power. So that's the key. That's what we're trying to deal with. Now, the next one is very similar to this one. It's actually starts with this big broken out part right here, and I'm going to work backwards. So this part right here. Okay. So we have cosine. I'm just doing the formula in reverse. Cosine of 2x divided by 2 is equal to cosine squared x. Okay, so right here, I'm sorry, that's a minus. That's a, so that makes that sine. If it's addition, it's cosine. If it's subtraction, it's sine. So that's what we are going to use. So we have 1 minus cosine of 20x over 2. And so I'm just going to cut that in half, because that's all that's happening is it's being divided by 2. So that's going to be sine squared of 10x. Okay. So all I did was divide by 2. That's all that happened from here to here. Okay. So let's plug that in. So that's going to be sine squared 10x times cotangent of 10x. Okay. Now there's another formula that I want to remind you guys of. And that formula is cotangent of anything is equal to cosine divided by sine. And so I can try to simplify this down a little bit more. And so this will be sine squared 10x times cosine 10x over sine 10x. So that cancels out one of the sines. And this gives me sine 10x times cosine 10x. And there's even a formula for that if you get online and look for that. I do not think I have that on here, so I'm going to stop right there. But there is actually a formula that shortens that completely. So there are identities for everything. Now the point of an identity, just to kind of give you an idea of where to stop. The point of an identity is to try to get everything down to first power. So no squares, cubes, whatever. The second thing is to try to get it down to a single trig function, typically or preferably sine or cosine. Cotangent's not helpful. You know how I know that? I don't have a cotangent button on my calculator. What buttons do I have on my calculator? Sine, cosine, and tangent. And tangent is just sine divided by cosine. So you can always get things back to sine and cosine, and that is usually going to be the most helpful thing. All right, I'm going to stop this one right here, and then we'll continue on with triangles and talk about vectors. All right, so where's the stop recording button?